practices, most of your training will become useless. So the hands-on training is very much needed, and you have made it in place. I'm very happy to see that. And of course, data science have percolated into different all branches of science, because all we are seeing that most of the simulational programs which can be commercial simulational programs that which can be purchased, like a DFT, density functional theory program, like that, codes which are able to, which can be purchased, they implement lot of machine learning aspects into it nowadays, the recent editions. So we cannot avoid this developments in machine learning to be included in other branches of science also. Currently, we are running a course on machine learning for physicists in our Department of Physics. This time also it is running. Maybe in the next time we will be able to do it in a more elaborate way. So this is the status of machine learning. Now, in the coming decades, I think data science will rule the industry, and also data science. Of course, it is related to the people from statistics, mathematics, physics. They are not away from this basic theory of it. Of course, a proper training. Now the data science is going and rewarding back these sciences actually. Any sciences, if you study, you should be able to understand at least what is happening in data science. So I congratulate the organizers of this program to organize this in a very meaningful way, and I wish you all the success. Thank you.
Thank you, sir, for the very influential and informative speech. Now, I may request Dr. Muhammad Suhail, Technical Manager, Artificial Intelligence, SCGP Bangalore, to formally inaugurate this FDP.
Hello.
Yes, sir, audible.
Yes, sir. So, very good morning to all the dignitaries, Professor Vincent sir, Professor Kumar sir, and all the other faculty members of the Central University of Kerala, especially the Department of Physical Sciences. So, I'm indeed very happy, and it's my pleasure to be a part of this wonderful event. So which is catering to the faculty across the country. So I'm also happy to see that ATAL is sponsoring a lot of such activities in different institutions to bring the faculty across the country together and learn and get back some of the important aspects so that they can adopt them to their curriculum and to impart those knowledge to their students as well, so which is very essential in today's world. So sharing of knowledge across the globe is very essential. As Vincent sir has rightly pointed out, I even see that data science, though it is emerged as a interdisciplinary field from the fields of computer science, statistics, mathematics, machine learning, uh, you know. So all these together have made this possible to be a field which is not only a field of very high importance in the industry, but it is a field which is actually giving back to the society. So today, if we just imagine the various applications that you see of data science, ranging from consumer related entertainment, retail sector, be it the transportation or infrastructure, or the oil and gas industry, health sector, very importantly. So even to the military defense, so it is aiding a lot of applications. So and even to the agriculture, so not to the very least, agriculture is also an important application or the area which is receiving lot of advanced automation tools for the betterment of agriculture today. So it is definitely an important field that every one of us, not only from the branch of computer science, but every one of those who are into research, who are into academia, who are into industry should be aware of, because you are the in one or the other sense, you are the consumers of these applications, or you are the clients, and you are the ones who are driving these applications, because the data that these data science related tools process will be generated by you. Today, if you see, everything is on the internet, and we are almost like we are always connected to the internet, and thereby will be generating huge amount of data, uh, though it is our personal data or transaction data or business data, whatever we do process and keep it on the internet. So everything is digitized today, and when we have the digital data, and which is so enormous that analyzing such a huge data is not at all possible from the human level capacity, because it is so huge for us to process. And that is where the applications which are built out of data science will help you analyze such huge data and come out with lot of insights, which will give a lot of value in a way, like they may help you have better decision making, or maybe to build right products to the right people based on their current day's need. So this is where data science is also very important today. And as you can see, we are engaging this such a big event through online mode, which is also possible through the digitization. So even this, digital stuff can be application for data science. So I heartily congratulate the entire organizers of this event uh, to have planned such a nice way of deliberating the stuff to the faculty, and in the right time, basically. So yeah, even I happen to see the content that's planned for this week, and it is very nice and focused to the different areas, especially the applications that are planned out with some hands-on trainings will be very much beneficial to the participants. So I wish and request the participants to make use of this event and the content that you receive to the best possible extent, and extend it to your colleagues or your students, so that they'll also be in a current trends level, and they'll also get motivated. So the motivation that you get out of this event should be taken to your students, so that they get motivated. And when they get motivated, obviously they start learning. So the only way for them to make future ready is make them motivated. Once you make them motivated, they will come out of the comfort zone and start exploring new things, and you being the backbone try to support them. And that is how the gap that our honorable vice chancellor was quoting between the industry and academia can be eliminated, so which is what I feel. So with this, I just want to conclude here, and very thank to all the organizers for having me invited to this special occasion. Yeah, looking forward to you all to speak to you and to discuss with you. Thank you so much.
Thank you, sir, for your valuable words. Next, I invite Professor Dr. R. Rajesh, Head of the Department of Computer Science and Director of IQAC, Central University of Kerala, to felicitate this program with his special address. Over to you, sir.
Respected Professor Vincent Matthew, Dean, School of Physical Science, keynote speaker of today, Dr. Mohammad Suhail, and other keynote speakers, Professor V. Balasubramaniam, my colleagues, Dr. V. Kumar and Dr. Manohar Naik, Dr. Taslima, and all other dignitaries, faculty members, research scholars, and my dear students. It is a very happy moment that AICT has sponsored several events, and this is one of the events that we are organizing for the last 2 to 3 years. And this particular event, especially the workshop, ACT workshop on data science, especially the advanced level, as already mentioned by Dr. Mohammed Suhail, that it has application across the disciplines. It has application across the disciplines, and it has huge employment opportunities internationally. The number of employment that is going to come in the next few years is tremendous. And what is needed is exactly the strong background in mathematics, strong background in statistics, and good logical skills. This is what is importantly needed to become an expert in data science. Strong background in mathematics, strong background in statistics, and logical skills. Very, very, very important as part of the data science course. And this advanced level workshop will definitely will be a stepping stone to become such an expert. Definitely you are going to hear from a lot of experts, including Dr. Mohammed Suhail. You will be knowing his depth of knowledge in his talks in the coming day talks, the depth of knowledge that is going to give to you through several talks, especially the programming behind the data science. And definitely you all will be enjoying from all the speakers throughout these 5 days. I hope all will take benefit of this, and this will consider as a stepping stone to become an expert in data science. We need all participants' support in all future activities of our department, because we know that all participants are faculties and they will be expert in some other disciplines, and this is the right time to request for some collaboration from other faculties who are involved in this workshop in all future activities of the department. This is how we can really become a learning hub to learn several things interchangeably. Something called collaborative learning, we say. So we expect all the support from all the participants, and I'm not extending more. I wish all the best for all the participants for enjoying these 5 days. Thank you all.
Thank you, sir, for the valuable message. Now I invite Dr. S. Manohar Naik, Assistant Professor, Department of Computer Science, to propose vote of thanks.
Respected Professor Vincent Matthew, sir, Dean, School of Physical Sciences, Central University of Kerala. Respected Professor Rajesh R, Head of the Department of Computer Science and Director of IQAC, Central University of Kerala. And respected today's Chief Guest and Keynote Speaker, Dr. Mohammed Suhail, Technical Manager, Artificial Intelligence, ACGB Bangalore. And my colleague, Dr. Taslima Madam, Assistant Professor, Department of Computer Science, Central University of Kerala. And Dr. Kumar V, convener of the 5 days FDP on data sciences, and all the faculty members of Central University of Kerala, students and participants, good morning. Now we have come to an end of inaugural function of 5-day FDP on data sciences, that is advanced level. First, I would like to express my sincere thanks to our Dean, Professor Vincent Matthew, sir, for accepting our invitation and to preside over the function, and for his excellent support while conducting any type of events in our department. Our special thanks to our Professor and Dean Vincent Matthew, sir. Thank you very much.
Thank you.
Thank you, sir. Thank you, sir. And next, I would extend my sincere and heartfelt thanks to Professor Rajesh R, Head of the Department, Central University of Kerala, and Director of IQAC, for his great support and encouragement to organize this FDP. And sir always encourages to the department to organize various events. And sir, actually, the Rajesh R is a key person behind for every event, and a backbone for the department, and not only to the department, he is for the university also. So our sincere thanks, I would like to express my sincere thanks to our Professor Rajesh R and Head and IQAC Director. Thank you, sir. Thank you very much for your support. Thank you, sir. And then I would like to express my sincere thanks to today's chief guest and keynote speaker, Dr. Mohammad Suhail, for accepting our invitation and coming over here. And I would like to express my sincere thanks to my colleague Dr. Taslima Madam and for his support and all type of encouragement to organize this event. And we express our sincere thanks to ATAL Academy for sponsoring fund and support to organizing this 5-day FDP. I would like to extend heartfelt thanks to all the faculty members from other departments of Central University, Kerala, and teaching and non-teaching staff of Central University of Kerala for their support, and even media people and finance department of Central University of Kerala, and to make this event grand success. Thank you very much. And I would like to thank all the students of our department who worked with us and to organize this event. And finally, I thank all the participants for active participation, and I hope you may make use of this 5-day FDP on data sciences to a great end. Thank you, one and all.
Thank you, sir. Thank you very much.
Thank you, sir. We once again thank all the participants for joining for this inaugural session. Next, we will be moving on to our technical session. The first technical session will be handled by Dr. T. Ramakrishnadu from Department of Computer Science and Engineering, NIT Warangal. Once he joins, we will start our first technical session on data science applications and challenges.
Yes, yes. Sir will join within 2-3 minutes. Please on hold.
Okay, Dr. Rajesh?
Sir.
Yeah, I am just
Vincent, sir,
leaving.
thank you, sir. Thank you.
Okay,
very
okay.
much.
Yeah,
Thank
I am
you.
leaving.
Okay,
Okay,
sir.
thank you.
Thank you so much, sir.
Thank you once again.
Vincent sir and Rajesh sir. Thank you, sir.
Thank you.
Sir, good morning, sir. Ramakrishnadu, sir.
Yeah, good morning. Good morning, sir.
Good morning, sir. Sir, just now inauguration over.
Oh, good. Congratulations.
Sir, shall we start?
Yeah, sure.
Please start. Aditya, continue.
Good morning, sir. Welcome you to this FDP to handle the first session of this 5 days FDP on data sciences. And Dr. T. Ramakrishnadu is currently working as an assistant professor in the Department of Computer Science and Engineering, National Institute of Technology, Warangal. He received his BTech in Computer Science and Engineering from JNTU, Hyderabad in 2001, MTech in Computer Science and Technology from College of Engineering, Andhra University, Visakhapatnam in 2004, and PhD in Computer Science from the Department of Computer Science and Engineering, NIT Warangal. He joined NIT Warangal in 2006 as a lecturer in the Department of Computer Science and Engineering. He has 18 years of experience in teaching various computer science papers. He has published several research papers in international conferences and journals. At present, he has 5 PhD scholars working in the field of big data analytics, data science, and machine learning. Currently, he is executing an R&D project in the field of data science and machine learning, sponsored by SERB. He has served as the program committee member for many international conferences like IEEE Indicon, IEEE CGBAS, etc. And he served as the session chair for international conferences held at University of Oxford, London. And Ramakrishnadu sir is a resource person to many faculty development programs organized by UGC, AICTE, TechCube, ATAL, etc. Presently, he is a member of the Board of Studies for many engineering colleges in India and a member of Standardization in Artificial Intelligence Technologies Working Group, Department of Telecommunications. He is a member of IEEE Computer Society Technical Committee on Data Engineering, ACM, CSI, and UACC. With these kind words, we welcome you, sir, to this FTP.
Yeah. Thank
You may
you.
start the session now.
Yeah. Thanks for introducing me, Aditya.
Thank
Yeah.
you, sir.
I'll share my slides. Yeah. Is it visible, my slides?
Yes, sir.
Yes, sir.
Okay, right. Yeah. A very good morning to all of you. Today in first session, we are going to focus on the data science challenges and applications. Then in the next session, we'll focus on the introduction to data science and the life cycle of data science product development and other basic concepts in the data science. Yeah. Yeah, we'll focus on just, I'll introduce the historical perspective of this data science. Then what are the challenges are involved when you are designing a data science model for a particular problem statement, the particular application? What are the challenges are involved at each stage when considering the different stages of the phases of the different phases involved in the data science model development? What kind of challenges the data scientist is going to face or the model itself will face? We'll see the details of the challenges. Then the applications. A large number of applications are available. This data science is not a domain belongs to the particular, something like the particular department or the one. It is a multidiscipline. A large number of applications are there, and here the data science modeling techniques are used in different engineering domains and other domains. So we'll see the details of all the applications of this data science.
So sorry to disturb you. In case you are moving the slide, we are not able to view it. We are only on the first slide.
Is it?
Yes, sir.
Just a minute.
Yeah, now we can see the slide of data science in the recent year of data science.
Let me share it again. Yeah, first I'll stop sharing. Is it visible?
Yes, sir. Visible. Outline is there.
Yeah. Now this?
Yes, sir. Yes, yes.
Okay, right. Thank you. Yeah. This is the data science. In recent years, it is the buzzword. Just for an introduction, let's have who was proposed this data science, who coined this data science word, and when it was started. Just guess how many years back it was started? Because in recent years, we, the computer science faculty, and the other engineering domains are focusing on the data science. And we are all offering these kind of training programs. And we are offering a subject for UG students and PG students. And some of the engineering colleges started a PG program and the UG program in data science. So when it was started, is it 5 years back? No. 10 years back? No. As per the literature, in 2001 itself, it means almost 21 years back, William S. Cleveland was used the term data science first time in the history. He mentioned, I'll show you his research paper, the data science, an action plan for expanding the technical areas of the field of statistics. It was published in the month of April in 2021. Just I'll show you this. Look at the research paper. Published in Statistics Research in the year 2001. This is an action plan for expanding. But that is the prediction of a particular, the role of a particular concept. After 10 years, 20 years, what kind of attention this particular concept is going to get. The need of a particular concept, a predicting. So without using learning algorithms, he predicted the importance of this particular domain 20 years back. But that time, the focus was less. Later on, got good focus, especially in last 5 years. We're all thinking about the development of a data science model to answer varieties of questions raised, to solve varieties of complex problems which are involved in the data, to extract interesting patterns. We are all thinking about this data science and its use. In his research paper, he mentioned an interesting quotation. This is the quotation. Knowledge among computer scientists about how to think of approach of analysis of data is limited. So we're all thinking about the data science development, the data science model development using a particular programming language or the programming tool. If you are comfortable with the data, if you're comfortable with a particular language like the Python language, you'll think that you can build a data science model. But that is not sufficient. Why? Because he mentioned in his research, it is like the knowledge of computing environments by a statistician. So how a statistician, how much knowledge is having in the computing environment to develop or to code a particular model. Like that, the computer scientists are also having a limited knowledge on the data analysis. So what is required? Merge of the knowledge, the merge of these knowledge bases, it produces a powerful force in the innovation. But these two, just the statisticians' knowledge and the computing knowledge is not enough to solve the varieties of problems involved in different domains. So what you need, the domain expertise is required. Let me give an example. If you want to analyze or if you want to build a model for a particular application, something like the healthcare data, you're not in a position to decide what kind of application is required. What are the expectations? What is the expected outcome from the model? As a computer scientist, you're not in a position to estimate exactly. You're not in a position to define exactly what is required. And also, when the data is given to you, you need to understand the data, especially the initial investigation on the data is much required, much needed. For that, the domain knowledge is required. Suppose you want to analyze or you want to understand health of a particular building or the structure. You have a lot of data. But when you are going to the data, when you are building the model for that particular data, first you need to understand what type of data it is. Sorry. And when you are doing the initial research or the initial investigation on the data, you need the domain expertise who can explain to you clearly, who can give you clearly the outcomes of this particular model is the domain expert. You need a civil engineering expertise in that. That's why, in addition to the statistics and these computing knowledge, you need a domain expertise. That's why some of the researchers mention that it is a multidisciplinary topic or research or domain. For defining or building the model, you need a computer knowledge. There you are going to develop a piece of software for the model, this data science model. And you're good in using machine learning algorithms to understand the data or to extract an interesting patterns from the data. That's why the knowledge in development of a software and using of the existing techniques which are good for the data science and the mathematical knowledge, the statistical knowledge, this understanding the data by applying these statistical methods, and you need to do the traditional research and the mathematical models which are useful for building the data science models. And this model you are building for a particular domain. There are a large number of applications. Why everybody thinking about the data science nowadays? Because of its applications. There are the large number of applications. Later we're going to see every domain is required. Every domain is expecting this kind of data science knowledge or usage. That's why everybody thinking about this. And here, that the person who's having the knowledge in that particular domain is required. Then In addition to the domain knowledge and the mathematical knowledge, the computing knowledge also require the business knowledge. What kind of profit you are going to get? What kind of uh, the how to use these kind of patterns which are extracted by the data science model, and how it's going to improve the business. At the end of the day, we should get a kind of profit from the model. What kind of profit, what kind of business uh, business is involved in the model building. So you need the business knowledge also. But some of the researchers bit expanded this, not only these models, to get a sustainable and the good model, good data science model, you need to apply the varieties of you need to have the knowledge of other models. Lang Bing Kao proposed a research paper. As per his research, he mentioned that not only the computing, just now have seen the computing knowledge is required to build a data science model, and the statistical knowledge is required, and the business, this the management knowledge, because they are going to suggest what kind of what they're expecting from the patterns, or from the output from the data science model, how to use that for improving the business kind of one will give the what is required from their point of view. And also, in addition to these, they mentioned that the informatics knowledge in the informatics is required. Varieties of informatics tools and techniques are involved, are required for the data science model building. In addition to this, communication from the one is the communicating the results to the end users or the stakeholders is an important one, and also the sociology kind of additional knowledge which helps you to build an interesting sustainable models in the data science. So this is a very brief introduction about the data science. Let us see what are the challenges involved in building this particular model. When you are going to the model building, data science model building, very beginning phase or the initial step is the problem identification or the problem definition. Unless the problem is defined clearly, unless the problem is defined, the exact problem is defined, it's not possible to build the model. It's not possible to build an efficient model. That's why the data, what is this, the problem identification is an important one, because the end users are not in a position to define exactly what they want, what kind of knowledge what kind of knowledge they want to extract from the data, what kind of patterns they want. They don't know exactly. The end users, the stakeholders. Take a simple example: the market basket analysis, the supermarket data. They don't know exactly what kind of patterns they want. This says that I have a lot of data of my customers, have a lot of data of the transactions which are performed previously. Can you build a model to analyze this data? Simple, with a single statement, a one-line statement. This says that what they are going to request you what they want, but they don't know exactly what is the expectation from this particular one. As a data scientist, when you are building the model, you need to define what kind of problem it is, and how to build a model for this particular problem. You need to focus on this, the problem identification. That's why defining or designing a clear, precise problem is an important task in the data science models. Define the problem by discussing with the stakeholders. Alone as a data scientist, you're an expert in building the models, but you're not in a position to define exactly what kind of problem it is. So you need to discuss with the stakeholders who's going to use this particular model at the end of the development. What are their expectations? What kind of model they are expecting, and how they are going to use the model. So by sitting with them and discussing with the stakeholders, you need to define the clear problems. And you need to define the problem with the domain experts, not only the stakeholders who are going to use, the end users, but you need to discuss with the domain experts who are having a good knowledge in that particular domain. If you're analyzing the e-commerce data, you're analyzing supermarket data, or you're building the models for other engineering problems or in other engineering domains, you need to get the a kind of support from the domain expert. That's why you need to discuss with the domain expert before defining the exact problem. Do the initial research to define the exact problem. This initial research and the need and this particular domain and its need, and you need to get a basic knowledge, and that knowledge helps you to define exact problem. What kind of model is required? Then only it is possible. If the problem is defined clearly, if you are able to understand what kind of knowledge, what kind of the patterns they're expecting, if you are able to understand clearly, then only it's possible to identify the exact model. What is that? The data science model, something like the techniques, varieties of techniques are available. The machine learning techniques, using of a particular statistical technique, and the machine learning technique is possible if you are able to define the problem clearly. That's why you need to focus on the problem definition. That's why this is the first challenge. Once the model is built, once the problem is defined and the model is built for that, and the model is you're going to release the model, but when you are extracting the patterns using that particular model, those patterns are not useful for the decision making. The patterns, what kind of knowledge you are extracting from the model is not useful. It's not useful for decision making and not interesting the patterns. If that is the case, you redefine the problem if required. Based on the need of that, you need to redefine the problem. What you defined initially, it's not useful. Then data acquisition. Here, the success is depending on the based on the data. Success of the data science model is depending on the data, because we are going to analyze, we are going to understand, we are going to predict, we are going to get the patterns from the data only. But when you are focusing on the data, when you are trying to extract the data, when you are trying to extract the data from different sources, will find a large number of sources, that is, multiple sources of the data. The data is coming from this particular location, this particular location, this particular location. When you are extracting the data, now you want to build a model. And this model is going to extract the data from these sources. Here, the major challenge is involved in the data extraction. Let me give an example. Suppose you are extracting the data from a social media sites. You want to do the analysis in the social media data. And the different social media sites are providing APIs for data extraction. With the help of the API, you need to define the parameters only. You need to define the attributes only. What kind of data you want? Suppose you want the elections data. You want to analyze the elections data. So hashtag-based extraction you are going to use. And the time period, which period of the data you want to extract. And this is based on the hashtag. Or suppose you want to understand the users, the social media users. You need to extract the posts posted by the different social media users. And for that, a different kind of change is required in the application. Just you are going to define what you want exactly. So there the APIs are available. And after extraction of this data, and you need to apply the varieties of pre-processing techniques before feeding the data into the model. That's a different challenge. But this is the social media. You will find an API to extract the data. But the other sources, suppose you have a data warehouse or the database. You want to extract the data from the warehouse systems from the databases. You need to define the exact, you need to define a function or an application. It's going to extract the data from the data warehouse or the databases, the relational databases or the other types of databases. So you need to focus on the data extraction methods, the functions based on the type of what type of source it is. And in case of multiple sources, you are building a model. This model expects the data from a social media and also expects the portion of the data from the data warehouses or the relational databases or some other sources. Those sources are storing the data in the form of the spreadsheets or Excel files or the text files. Maybe the model is expecting the data from all these sources. So you need to use the existing APIs, or you need to define your own APIs to extract the data from the different data sources. So you need to define the exact methods for extracting data from the different sources. What is that method? If it is available, using. If it is not available, developing. Then another challenge is involved in identifying the existing data acquisition methods. What are the methods that are available? Identifying and using those methods for the data extraction. So this is another challenge in that. If it is not available, developing a suitable data extraction functions. That means you need to develop your own functions for extracting the data. You take some other example. You want to analyze the weather data. For that purpose, you are using a different sensor devices to collect the weather data. And these sensor devices assume that are pushing the data into a source, something like a cloud server or some other server is available, and these are continuously pushing the data onto the server. You need to define the exact suitable model, suitable method to extract the data from the source. If the data is available in the cloud, a different kind of approach is required. If the data is the sensor devices are pushing onto the local server, a different kind of extraction functions or methods are required. That's why you need to focus on the data acquisition and the extraction, accessing the right data. The huge amount of data will find in the data sources. What is required exactly? What is your target? What is your target? Based on the target, you are going to build the model. Based on the target, you define the problem. Based on that, you need to identify which kind of data is required. You consider the social media. Social media sites are having a huge amount of data, right? But based on your need, you want to analyze the people. Take an example, you want to analyze their emotional feelings, or the emotions of the different groups at a particular time period. Consider this pandemic. During the pandemic period, what are their emotions? You want to extract the emotions from the social media data. So there, what you want to understand the emotions based on their posts. But the time period is there, and the during this time period, you want to extract a portion of the data, and you want to build a model to get the patterns from that, to understand their emotions. So that is your data. You need to access the right, correct data. If you have unnecessary data, if the data is not useful for analyzing, or the data is not useful for extracting patterns, the good patterns, the interesting patterns, right? And the important thing you need to focus it here is getting the permissions for accessing the data from various businesses. Suppose those businesses are maintaining the data in local servers. You need to get the permission to extract the exact data. So gaining the permissions from that, you need to access the data in an appropriate format. Which type of data your model accepts. You need to extract that. You consider the varieties of sources are allowing you to extract the data in .cvs form, text format, and the JSON file, or some other XML files. So varieties of formats you can extract from the data. But how this model is built, based on the type of data the model is going to accept, you need to extract the same type of data. So you need to focus on the data accessing and what type of this one. The major challenge involved in the data sciences is the data is coming from multiple sources. Because of the multiple sources, a single solution, a generalized solution, is not sufficient, or sometimes not useful sometimes. That's why the specific approach the data extraction is required. So data available at more than one sources. What is that source? Which format the source is maintaining the data? What kind of data? Kind in the sense here useful for building the model and analyzing. So the portion of the data is coming from this source, and another source, some other portion of the data you're getting. So you need to combine this data, you need to feed the data into the data science model. Then only the patterns what you are getting are useful or useful patterns. If the data is coming from one source, is not sufficient. So you need the data from multiple sources. So another challenge is extracting the data. Data extraction methods, developing the data extraction methods for extracting the data from different sources, the multiple sources. Transforming the data into an appropriate form. Which kind of format, which type of data the model is accepting. Based on that, you need to extract and you need to transform the data into that particular form. Suppose you have a relational databases. From this, you extract the data using your the standard method of query language and export this data to .xml or .csv file. So because the CSV is much useful, and the pattern, what is that? The format. This data is available in rows and columns because your model is going to accept the data in that format only. Or you can extract the data from a particular the model developed, a scientific model developed to collect the data from different sources like the machinery. Different machines are running and you want to understand the health of the machine. The data collection devices are collecting the data and exporting the data to .txt file, right? It's a text file. But your model accepts only the rows and columns, so you need a kind of what is this? The conversion method. Kind of conversion approach is required to transfer the data from this to this model. Okay. Another challenge, in the data science is identifying the exact suitable features from the data. But you may not find the required features in the large data. Suppose the data is extracted, a large number of the attributes are there in the data. What are the attributes are useful? Maybe some of the attributes are useful to understand the data. Some of the attributes are useful for feeding the data into the model. But those features or those attributes are not sufficient. Not enough features. If those features are not enough, what are the features available which are not enough to get an interesting one? Then you go for deriving data. Deriving new features from the existing one. New features from the existing one. You consider the social media, or you consider the supermarket data. Your supermarket data having the data, there's a detailed data. For example, the detailed something like hour to hour data, the sales from hour to hour. But you don't want exactly the hour at particular time, at what time this product was sold, and what is the exact time and other information you don't want. You want to know the demand of that only. So this hourly basis data is not required. If it is not required, in the hierarchy, you in the concept hierarchy, you go up one level from the hourly data to the day-wise data. Day-wise data. You can use day-wise data, and this is the day-wise data is derived from the hourly data. So summarizing the data, the day-wise, the summary data is not available in the original one. Maybe this is not useful. You go for one more level in the hierarchy. This is a weekly data or the monthly data you want, or the quarterly data based on the particular concept. You go up in that particular concept in the hierarchy and derive this kind of data from the existing one. And that data may be useful for your model. The data gives you to understand the hidden patterns. Like this, deriving the new data, deriving a new features based on the existing one. So identifying the suitable features and then creating the required one. Once data sources are identified, the methods are defined for extraction of the data, and the data is available before feeding the data into the model. This is your model. These are the sources, the methods used for extraction of the data. In between this, you need to do the important task, that is the data cleansing, the cleaning of the data. Very much needed. And the challenging task is this, as per the literature, 50 to 60, even more percentage of time they're spending for the data cleaning. This is pre-processing the data. In pre-processing, the data cleansing is an important task. Why you need? Just ask a question. Why you need to clean the data? You want to analyze the weather data. You have varieties of sensor devices. And these sensor devices are storing the data onto this, collecting the data and storing the data onto this. This is the data storage. Right. During the data collection, because of the limitation of the devices, data collection devices, because of the malfunctioning of the data collection devices, are collecting the data with a lot of noise. Whatever the data is required for the analysis for your model, not only that portion, it is also associated, or some other noise is associated with this data because of this, the devices, data collection devices. These are the automatic devices. Suppose you are using an applications and asking the users to fill the data. That means you are collecting the data from the users. They thought that the data, some of the features are not useful, and they added the additional information. You need to clean the data. You need to identify the unnecessary data exists in that. You need to remove the data, unnecessary data, and which kind of data you want. Only that data you are going to feed into the model. The important thing you need to remember, the quality of the patterns, quality of the output of the model is depending on the quality of the input data. That's why you need to do the data cleaning or the data cleansing. Yes. Really, it's a big challenge, Varieties of techniques are available. You need to apply all the techniques. Some of the machine learning techniques, some of the data mining techniques are required here. The data cleaning, some clustering techniques, some classification techniques you can use for cleaning the data. What kind of cleaning technique, data cleaning task is suitable, required? Identifying is the challenging task. Identifying the suitable task, suitable data cleaning task is an important, and it's a big challenge. And also the data, what you are expecting the data format, it is not in that particular format. There the data transformation is required. So removing unnecessary noisy data and generating what we call the, deriving the new attributes, and also the formats is also a kind of pre-processing, and here the appropriate format. So if the data is not in appropriate format, you need to convert into that particular one. So like this, you can take any source, you can take any application. What kind of application you are using for collection of the data, either an automated process or the something like the data collection from the users, well-defined process. In both the cases, data data is coming. And another important thing, when it is coming from the data sources to the data storage, data collection devices to the data storage device, there is a chance to associate some kind of additional data during the data transfer. So that because of the data, because of the data transfer protocols, the applications which are defined, based on that, some additional data will get, and we need to remove that. That's what the almost 60%. And the quality of the data, quality of the patterns, output patterns are depending on the quality of the input data. If the input data is not that much quality, you need to get the quality by identifying the other, what is that, the missingness one, something like missing values. One of the pre-processing technique is the missing values. We may not find the exact one. Take an example. These are the IoT devices, and IoT devices are installed at different locations and are collecting the data continuously. At a particular time, this each device collects the different kind of data at a particular time. Assume that this device K is unable to respond, and because of this, the particular column, if you are preparing the data like this particular column is a null value. It is a null value because the no data from this, right? So what to do with this, the missing value? So you can use what is that, the filling the missing value techniques to get that particular one. Or you can use some of the learning techniques to estimate or to predict what type of data is going to extract, is going to collect at that particular timestamp based on the other parameters. You can fill the data, and by doing that, you will get the quality of what is the quality of the data. So you need to understand the quality of the data, whether it is a quality one, or if it is not, then you need to improve the quality of the data by using this kind of the techniques, varieties of techniques. Quality of the output patterns are depending on the quality of the data. That's what I mentioned. And data quantity also, right? Let me explain why the quantity is an important challenge. You have a model, you build a model, and you are training the data. You have a data D1, and you are training the model then you are trying to predict or classify based on this with the new data. So whatever the data you are using, it's a small data. And this small data is not sufficient. It's not sufficient to build the model or to train the model. Even both the cases, while building the model, whatever the data you are using, it's not sufficient to build the exact the what we call the conditions, right? And while training the model also, this is not sufficient. You have a small data, and what you are trying to here classify or predict, those the classes are what we call not useful, or it's not classifying properly. That's why the accuracy of the model is very low. Here, the data quantity is playing an important role. So it is very difficult to decide at the beginning of the model building, is this quantity is sufficient to get the exact patterns? No. Sometimes you will understand that at the end of the model building, right? Based on that, you need to rebuild the model. That's what valuable data is not sufficient to train the model or exact right patterns, extracting the right patterns from that. The imbalanced data. Another challenge involved in model data science is because of the imbalanced data. Data is not distributed. Suppose you have the class labels. You have the class labels. From here, starting label 1 to the label 2. Maximum of the data is like this. This is left and right varieties of, assume that this is the low and the high. When you are arranging the order, all these class wise, this is class label wise. This data is a skewed data. And the class labels, maximum of the class labels are from this particular portion only. And the model, the model you are building from, when you are building the model from this kind of skewed data, you will get a biased model and biased patterns. Something like the 70% are positive cases, 60%, 30%, because this percent is very low. The data is not balanced properly, balanced all the class labels. You can take any kind of skewed one. It is skewed like this. This is low, high. Only the high class labels are there. You have a student data. Just consider the student data. In your data, only good students are there. Students' marks are minimum marks to the maximum marks. Only good students' data is here. So what are the patterns you are going to get from this? And when you are trying to use the knowledge for decision making, for generalizing the decision, it looks like only good students. That's a good performance information only is available. You are going to get the biased patterns towards the good. So you need a balanced kind of data. So all the class labels, the equal distribution of the data to all the class labels is a balanced one. So imbalanced classes are the common problem in the data science and machine learning. You need to solve that problem. Another problem is with the data only, the overfitting with the overfitting. When you are building the model, when you are trying to classify, when you are trying to extract the patterns from the model is overfitting. It occurs when you are building a model from the training data. Training data is too well. It's going to understand clearly the training data. Because of that, it's going to overfitting, or sometimes the same training data and the testing data, when you're using the same, it's going to overfit. It's going to give 100%. Okay? So you need to understand the challenge involved in overfitting in the data science model is overfitting. You need to understand what type of data, why you're getting this particular one. Something like many times, many of the developers are just using the existing techniques and feeding the data into the model, and the model is giving some knowledge, some kind of output. They're not in a position to decide why this particular output is coming. What is the reason behind this? Is it acceptable one? If it is not acceptable, what is the reason behind this? And what kind of changes are required at the model building or the input data? That is another important thing you need to focus. And the very, very important one is the communicating the results. In the data sciences, facing another problem is the communication of the results. What are the results you are getting? In the data science, how much attention is required for the data, for the model building. The equal amount of attention is required for presenting the results, for communicating the results. That's why data visualization is very important, really playing an important role. If we are not able to communicate the results properly with the stakeholders, there is no use of building a model. There is no use of constructing a particular model and using the model for analysis. That's why the visualization, which can here in the data visualization, you will find a large number of techniques, data visualization techniques. It varies based on the type of output. For every just a scatter plot is not sufficient for every output. Just the bar chart is not sufficient for all types of results. Just the pie chart is not sufficient. Based on the particular domain, based on the particular application, based on the patterns you're getting, based on that you need to decide, you need to identify the suitable pattern. The visualization method, data visualization methods. Sometimes without visualization, with the numerical results, you can communicate with the stakeholders. That's understandable sometimes. It's not always. That's why this communication of the results, communicating the extracted patterns is another important challenge. The tools is suitable to communicate the results. Which tool is suitable? Identifying the tool is also an important one. What are the suitable methods to communicate using that tool? So maybe you are the data visualization tools you are using. In that visualization tool, which particular model is useful, right? This is the communication of the results.
Sir,
Yeah.
Sorry to interrupt you. I just request you to provide one more example for overfitting data, because uh, how it is how it can be seen, especially in management domain.
It is not the space, not only a particular domain. It's not to the specific domain, the whether it is a management or scientific or some other kind of one. There is a chance to get the overfitting results. That means what you are expecting, you're getting more than that, because of the model is not trained properly. The model is the kind of data you are using for building the model and training the model, testing the model, the same kind of one. That means, let me give some classes. You have specific classes of the data, and you build you build a data science model for that, and the same kind of one you are using for testing. Because of that, it is showing perfectly, and it's showing 100% is correct. And based on that, you can decide the model is perfect for classifying that. So that's why, the varieties of test cases are required to test the model.
Okay, so different samples have to be taken into
Very
account.
much needed, very much
Okay,
needed.
okay, sir. Thank you.
Then only it's possible to deploy. Then only it's possible to decide the model is good for deployment.
Correct.
Right?
So this is
Before
basically
going
to
for that,
identify the biasness in the model.
yes.
Okay, okay, sir. Thank you.
And you need to follow the important security features, because the complete data is available with you when you are building the model, when you are communicating the results. You need to take care. An important thing is the data security. These three are the very important. Confidentiality, based on the sensitivity of the data, how sensitive this particular data. Based on that, you need to decide whether the results are publishing the results is okay, or some other kind of what we call the trimming or fine tuning is required based on the sensitivity of the data. And the another important one is the integrity of the data, accessibility. These three important security features you need to maintain, because the complete data is available. That portion of the data is not allowed to publish. The portion of the data is not allowed to use for extracting patterns and publishing the results, because that portion is the sensitive one. How do you understand as the data scientist which particular feature or the attribute is an important or a sensitive attribute? Only the domain expert. That's where the domain knowledge is required. Right? And this is the people who are building the model. They are facing another important challenge is they are having a less knowledge, lack of domain knowledge. Because of the lack of domain knowledge, they're not able to build a suitable model. Right? That's why either earning the knowledge, the domain knowledge, or using the domain experts is an important one. That's what we have seen in the beginning. Domain specific data collection, when you are collecting the data to a particular domain and getting the knowledge into the domain, or using the particular the domain expert when you're extracting the data. And the another challenge in the data science is the professionals who can build perfectly the model, the skilled professionals who are good in building the models. Also, there is a shortage. That is also another challenge, especially when you are considering the data science, the industry point of view, or the what we call the user's point of view. There is a lack of professionals, skilled professionals. That's why there is a big demand, and because of the shortage or the lack of skills for the professionals to build, analyze the particular data. Then identifying the issues. This is, it looks like this is the less important one, but this is also an equally important one. In the entire process, we're going to see various phases involved in the data science model building. We'll see the varieties of phases later. At any point of time, whether you are doing the data collection at the data collection time, or the data pre-processing, or the data model building, model training, model testing, communicating the results, at any point of time, you need to identify the issues involved in each one. Issues, because of this issue only, the model is unable to unable to produce the exact output. So identifying the issues during the product development and the deployment is the key issue in the data science. So these are the varieties of challenges are involved. These are generally considered from the literature, and you can add some more additional challenges. So this is the end of the challenges. Then let us focus on the applications of this data science applications. Why, in the beginning only I asked a question, why this particular domain is getting the popularity? What is the reason behind that? Because of the large number of applications. Let us consider one by one applications. Just a minute. Let us consider the varieties of sectors and this general sectors and the domains, engineering domains. If we are going to consider the banking sector, a fraud detection, it happened because of the previous transactions. The identification of the fraud, detection of the fraud, and for that you need to build a particular model analyzing the customer profiling. You are going to identify the fraud based on the customer profiling and the past expenditures, the utilization, or how the patrons were there previously and how the patrons are there now. Based on that, you can identify the fraud is involved or not. And also in the banking sector, the another major application in the banking sector is identification of the risk factor, the detection of risk. So this you are going to get by analyzing the customer profiles. So you are going to analyze the customer profiles, and based on that, that is their what we call how regularly they are paying the EMI for a particular loan, and what are the other additional the additional commitments are there for that particular application. Based on the customer profiling, analysis of the customer profiling, you can identify the risk involved in that particular the application. You can decide based on that whether approving the loan or not approving the loan. You can decide. And these are the major in the banking sector. You can use other applications also in the banking sector. When it comes to the healthcare sector, so very important the application in the healthcare sector, the data science application in that is the image analysis, detecting a particular disease and the causes for the diseases. Then based on that, then defining the suitable to cure the particular disease, identifying the process, defining the process based on the identification of a particular disease. For that purpose, it is largely used these data science applications, the models in the healthcare domain. In the genetics and the genomics, the data science or data science models are very much used. These applications enables an advanced level of treatment by with the help of the personalization through a research in the genetics and the genomics. So with the help of these data science models, you are going to personalize the treatment. Based on that, you can cure, and you can define exact process for that. In the drug development, the large in the healthcare sector, this data science is largely used in the drug development. So it's going to, the data science model is going to simplify the discovery process, the drug discovery process. And it's going to shorten the drug discovery process. Right? That's why it is used. And a kind of virtual assistance for the patients and the customer support is also possible here in the healthcare. So understanding the customers, understanding the patients and their particular problems and the other additional things, you are going to do the virtual assistancy for a particular patient based on his own data. And optimizing the clinical process, when you are doing the process for the person, optimizing the clinical process using this data science is possible. Internet search. Every day will search in the internet. A large amount of data will search in the internet. Thus, generally, it's going to deliver the best results for a particular search, the query. But this, which type of user, what type of data is regularly, what kind of data is browsing, and what he wants exactly. Understanding the user interest, based on the user interest, and providing the best results for the query, searched query, and that is then in the application of the data science model and customer analysis, largely used this irrespective of the industry. For every industry, the customer is an important person. That's why they're going to analyze the customers. For that purpose, these data science models are used. So varieties of tasks. The target is a different while analyzing the customer. This one, what are the items a particular customer is interested? What kind of the transactions is performing, and is interesting items. So the kind of one is the major one in the customer analysis. And targeted advertisement. Now in the current digital world, this is the major business. And the when you are searching for a simple thing in the any using any search engine or in the e-commerce sites, within a fraction of seconds, you are going to get a lot of suggestions. You are going to get a kind of mail or messages related to the products, and you are going to get the suggestions uh, from the products. How it is possible? Because they are understanding and identifying your interest, your needs. That's why a targeted advertisement is there. So for you, when you are browsing something, for you, you will get all the training programs which are related to the particular one. Or when you are browsing for a product, all the product based or the products details will find on uh, your page, or the searching page, or in your emails will find that. So it's going to display the banners on various websites is based on the targeted advertisement. Displaying the banners based on your interest. Recommendations, suggestions, lot of suggestions will get about the products, the similar products, who purchased this particular product, or who are shown interest on this particular product, how much percentage they shown, how much percentage of people are purchased this particular one. So we'll find a lot of recommendations, not only the product. You will find the recommendations for your interests. If you're searching for the music and the other videos, so you will get the similar kind of products, the recommendations. Advanced image recognition. So this advanced image recognition is with the help of this. Whatever the image you uploaded onto the social media site, you will get a kind of suggestion, that you tag your friends. So this is possible with the image recognition. So the group photo is there. In this, you posted that, but these are the people who are there in your friends group. You can tag to them, because this page in this particular photo, their images are there. So that is possible with the image recognition is there. And the speech recognition based on the voice is coming. It's going to the speech recognition products, all the speech recognition, the Google Voice, Siri, Cortana, these are all working on the speech recognition. They're also the building the models, training the models based on the existing data, and it is. So in the other cases, like you can consider the airlines industry, it's going to predict the flight delay, and based on that, it suggests to you the which particular the route and which particular class is best suitable for you, and it's suitable to buy. The kind of information it also provides. The gaming industry, also the data science is used. It's maximum of the games are designed using the machine learning algorithms. It's going to upgrade or improve based on the situation. Suppose a particular object is moved from this state 1 to the state 2. Here, based on the availability of the other objects, it's going to improve. It's going to take a decision based on that. That is, which particular move is the best. This move is best, or this move is best. It's going to choose the best move based on the availability of that. So it's going to this in the gaming sector. These models are also used in augmented reality. The virtual reality headset, it contains a lot of computing knowledge and algorithms, the data. These algorithms are going to work on the data available. This data is it will provide you with the best viewing experience by analyzing the data. These are the general applications. So all the people will use. But when it comes to the engineering domains, why the data science is getting the popularity and why the specific programs are started, because of this. Now it is sitting on top of all the engineering domains. In every engineering domain, the data science is required. Let us consider one by one. The civil engineering, what are the applications, these data science applications? In the construction, in the construction field, it's going to do the advanced predictions, and it's going to predict the risks. What is the risk is what kind of risk is involved in the project. So the prediction of the risk, and the real-time data analysis. You want to understand, you are constructing a building, or you have a building and you want to monitor its health. You want to analyze it, that for monitoring the health, you want to collect the data using varieties of sensor devices you installed at the different locations in the building, and those devices are continuously collecting the data and sending that, communicating the data with you, and you are analyzing the data and projecting that the real time health of the data, health of the particular building or a particular the structure in real time. So that's why it is used. And optimizing the process. So when you are defining the process, and is that process is okay, or any optimizations are required, yes, it's going to do that. The water resources, so it's going to identify the availability of the water resources, and it's going to predict after now the lot of water is there in the tanks at a different locations, and based on the level of the water and based on the usage of this water, after 2 months, what is the state, what is the condition of the tank, when the usage is like this. And there also you can use this machine learning, this data science models and traffic predictions. So all this the data science is involved in the traffic predictions. How many number of vehicles are moving at a particular time, and what is the peak the traffic at which time it's a peak, and which route is having a lot of traffic, and based on that, how much time it takes to travel from one location to another location. The predicting that based on the traffic is also used. And the data visualization in civil engineering, the data visualization is very important, because after prediction of this, and you can visualize the data, and for visualization you are using the data visualization tools and techniques. The mechanical, suppose you want to analyze, visualize, and you want to do the prediction. These techniques are used to assess the equipment performance. A particular machinery is working continuously. You want to understand you want to predict its a performance. You want to visualize the performance of that. So for that purpose, this is used, the data science models. Understanding the health of the machinery. You need to understand the health, the condition, continuously working, whether it is good to run for some more time based on the heat generated by the machinery. Is it required to give a time, a kind of rest? How much time is required? How much time is worked, and how much time is required to give the rest? And based on that, we are going to predict the failure of that. If it is working continuously at this amount of the data, and after some time there is a chance to fail. And this is happened previously in many cases. Based on that, we are going to decide this. And it's going to help this, data science models are going to help the manufacturers with the prediction of calibration and test results to reduce the test time while production, while doing the production in the manufacturing. We are going to do that. When you're considering the electrical domain, electrical engineering domain, the lot of the grids, the power distribution, the grid failures, and the power transmission, these are all in all cases, this data science models are used for predicting the risk assessment. What is the risk involved in this particular one? Real-time asset management. So you can manage the asset in real time. So it covers the key power system resiliences principles, and it deals with the unexpected outages. It's going to unexpected outages of the power system equip and the grid distribution when it is doing the grid dispatches. So there also you need to the data continuously collect the data and analyze, and based on that you can do the assessment, and you can manage and you can take the decision based on that. And the classification of weather impacts and the outages. What is the so how much outage is there, and based on that, what is the impact of the weather? So identifying and classifying the weather impacts and applications of the single smart meter analytics. So you can do the smart meter analytics and how the power is utilized, and which time and other kind of information you can do using this applications of the group of smart meters. Suppose you have the group of smart meters, and based on the data, and you are collecting the data, and you are analyzing the smart meters, how the data is used, and at what time there is a peak, and the load forecasting. This is very, very important one in the electrical domain, and you should be in a position to forecast at this point of this one at this particular time and amount of usage. So what is the feature that you need to forecast, and then the customer load profiling. So it's going to classify the historical readings of the customer demand, a particular customer, what kind of customer is, and how is going to use, and based on the behavior of the customers, you need to understand and where will use in the communications. So network failures, detection of the network failures, and the prediction of the network failures. And prediction of a particular device, network device failure rate, and cellular network traffic monitoring, how which particular cell or tower network are having the more traffic, and analyzing that, and network anomaly detection. Sometimes you will find a lot of problems when you are connecting, when you are accessing the net and other things, and identifying the anomaly in that is the one. And in the sleeping cells, detecting a particular sleeping cells in the 4G and 5G networks is also an important one in the communication one. Then when it comes to the chemical engineering domain, how it is used, these data science models, identifying the trends and patterns. These are essential requirement for the chemical industry to recheck an observation kind of. So you need to do that. And estimating the number of chemicals required for a particular reaction based on the previously happened thing. And predicting the crystal structures, what are the structures are required, and what are the crystal structures, and determining the materials suitability, which particular material is suitable for a particular what is the component, and identifying an alternative chemical. So you want to do a chemical process, for that purpose the one is not available. What is the alternative chemical for that? For the instead of using the current one, so the kind of analysis is also possible using this data science application. Understanding the best reactivity of a crystal for a different conditions. So what is the best one for these conditions, the temperature, pressure, and other conditions based on the domain and the domain expert? You can consider the other conditions. What is the best reactivity and which particular condition it's the best one? And guessing the predetermined result after reaction, what is going to happen, and based on the previous data you can guess, you can predict this. Even in the material science, material engineering, you can use in the advanced alloy development, modeling what type of alloy is the best to meet a specific set of needs. So this is the need. So out of available materials, which is the best one? And process failure prediction. So in every domain, this failure prediction is the common thing, and you need to build a model for that. What is the rate of failure? This particular one. Yeah, this is the last application. There are many other applications are available, and these are the references I used for preparing these slides. Any questions?
Participants, please respond. If you have any doubts, you can ask regarding.
So, sir, I don't have a doubt, but I have a question that I want to develop this data analytics in the text and social media. So, can you suggest me a good resource? I mean, though there are lots of resources, but if anybody has to develop a course in text and social media, then one thing I wanted to learn basically is how to use APIs. Okay. So what possibly could be the best source, and any book you would like to suggest or any course that you would suggest?
Yeah, there is no particular textbook for that. And based on your need, see what purpose you want to access the data from social media, right? Based on that, you need to decide. So based on the task, what is the exact task, and based on that you need to decide which feature is suitable in the API. And there is no what we call fixed one, something like there is no fixed textbook kind of one. What purpose you want to use the social media, what kind of data you want to extract, based on that the APIs are.
So for example, I want to use Twitter data to understand, the sentiment analysis, for example.
Yeah.
So I have a Twitter developer account. So this is how they give you the access to the data.
One thing I can say here, just having an account to access the data, you may not get exact data what you want, because through the free what is this the free data extraction, is it possible, you want to analyze the sentiment or the emotions of a particular group, only 1 week data, or maximum we will get the 10 days data of different users. You may not get the what we call the sufficient data with the free accounts. They are charging some amount, and by paying that you can extract the required amount of data, additional data you can. But just having an account is not sufficient.
Okay, sir. Okay, sir. Thank you, sir. And sir, any source from where, I mean, do you have any suggestion on the learning and development part in the text analytics, especially for the social media data?
Yeah, the suggestion thing is, generally there are textbooks, dedicated textbooks for that, the text analytics and the natural language processing especially. There you will find a lot of techniques, how to use this social media for a particular analysis.
Thank you, sir.
Yeah, and there are some.
Excuse me, sir.
Yes, yes.
Sir, what is the difference between the data analytics and data science?
See, in the analytics, you are going to generally these are looks like a similar, but in the analytics, you are going to focus on the available data and the techniques, but the mathematical modeling, the role of mathematical modeling is less in that, whereas the mathematical modeling is good and much useful in the data science cases, mathematical modeling. But the just analytics, you're not going to do the mathematical modeling there. You will understand what is the data available. You will understand the patterns using the available data and the tools.
Then what is the role in company they are doing by the data analyst, sir?
Pardon? What is the
What is
question?
the role in the company data analysts are doing? What is the role of the data analyst?
See, the role of the person is, it varies the application again. We'll see in the afternoon session varieties of data scientists. See, the data scientist, the role of a data scientist, we're not going to generalize. It varies from the application to application. Each type of data scientist having their own role, right?
Okay, sir.
And based on that only, we can decide what is the role of that person.
Okay, sir. Thank you, sir.
Sir, can we say that data analysis is the part of data science?
It is not like that the exact subset of this, right? In the data science, what we have seen in the beginning, the Venn diagram, it is a combination of all. You need to use analytical techniques, you need to use the mathematical techniques, modeling techniques, you need to get the domain knowledge. Based on that only, you are going to build a product, a model, which gives you the best in-depth knowledge, in-depth patterns from the data. You can say exactly this is the subset of that.
Oh, thank you. One more question, sir.
Yes.
One more question, sir.
Yes.
Sir, which one is the best model, and overfitted model or underfitted model? If we compare
Both are not best. Both are not. Right? A balanced one is required. That is
But
possible to decide by doing the number of number of times you need to train and you need to test and decide, is it okay for deploying.
Sir, but we have the good accuracy score in underfitted model, I think.
Yeah, that is also, you need to balance it. Just I got the good accuracy, my model is a good. You can't decide that. It is difficult to decide based on just accuracy whether the model is good or not. Right? You can depend on the accuracy only.
So we have to analyze more than one model to get a better.
Even the single, you need to use more than one variety of techniques and deciding which is the best one and to deploy. That is much needed.
Thank you, sir. Thank you so much.
Sir, I have one question.
Yes.
First of all, thank you for this session, because without any background, I understood most of the things, and the way you presented the things were excellent, sir. Thank you very much for that.
Thank you.
Do we need any specific software for doing this kind of analysis?
Yes, exactly.
Yes.
I'm
Which
going to,
softwares and probably how do we
tools and
ensure?
techniques, free open source tools are available.
Okay.
If time permits, in my second session, I'll show you one simple demo also using
Okay,
that.
that will be
Comfortably,
great.
you can work with that.
And
Yes.
do we need to know programming language before that?
Nothing is required. Without having any coding, you can learn.
Yes.
And at different stages, you need a support from the developers.
Okay.
But comfortably, you can build.
Okay. And sir, is it possible for you to share this PPT, because the PPT
Sure.
itself is very
In the evening, I'll share both the PPTs, this session and afternoon sessions one. Both
Definitely.
I'll share with the coordinator. You collect it.
Thank you. Thank you very much. Thank you very much.
Thank you.
Good afternoon, sir. This is Nalini. I have a question. Sir, you discussed about the imbalanced data, right, sir?
Yes.
So, do we have any techniques to balance the data?
See, this is a different kind of one. You can do using a pre-processing,
Yes, sir.
Please, echo is coming.
Yes, all of you mute your mics, please.
Yes. See, this balancing the unbalanced data, it is part of a pre-processing. You can balance it by doing the pre-processing one. Something like you have a lot of missing data. Let me give one example. You have 30% of missing values and a particular attribute, which feature you are using, that is not at all suggestible to use the data to build the model. That's why what you need to do, you need to find the best method to fill the missing values. Then the previously, without having missing values, the data was imbalanced. Now you may get a percentage of balance from the data. Using pre-processing techniques, you can.
Thank you, sir.
Thank you.
Sir, one more question from the chat box. They have some mic issue, I think.
Okay.
How to test the quality of the data?
Quality of the data, there is no fixed method for testing to decide the quality of the data. So varieties of this, something like by understanding this, what is the data is available, and any missing values are there, any outliers are there in the data, right? Based on that only we can measure the quality. There is no fixed technique for that. Then any other?
Okay, we'll continue. Sir will continue the afternoon also. So after the second session, you can ask more questions.
Yeah.
That's better, sir. Yes, sir.
Yes, you can.
Thank you, sir. Thank you.
Okay, sir. Thank you very much for your valuable session. Very detailed explanation from the participants. Also, we heard that. So without any background, also they can understand. Thank you, sir. We'll meet again at 2:30.
Okay, thank you.
Thank you, sir.
Thank you. Bye.
Sir, we have to use the same link, right?
Yes.
Yeah, same link. 5 days, same link.
Yes. Thank you.
Okay.
Thank you.
Okay, sir. Thank you, sir.
Okay, bye.
That's friends, please join back by 2:30, 2:25 you join.
Hello. Hi, sir.
Yes.
Yeah, sir. How do we supposed to give the attendance? I mean, is there any form we need to fill?
No. We are automatically tracking the attendance using a
Okay.
group add-on. So
Okay, got it.
no separate form.
Okay. Just the presence will be considered as attendance.
Yes, it will give the details of your name and how much time you attended.
Right. Correct. Okay, sir. Thank you.
Okay.
నేను చెప్పలేదురా, నేను చెప్పలేను. ఏం బయటకు వచ్చి ఇందాక బయటకు వచ్చి నిలబడి మాట్లాడుతున్నాను. లోపల కూర్చోమన్నప్పుడు మూసుకొని లోపల కూర్చోవాలి. అది కదరా ఎన్సీసీ క్యాండిడేట్ అంటే చెప్పింది చేయాలి, అర్థమైందా? నెంబర్ సెట్ నెంబర్ చెప్పరా.